So, in today's lesson, we are starting 4.6. Now, it's titled Completing the Square. That's where we're going. We're headed there. We're going to start that tomorrow. But before we can complete the square, we need to know how to solve quadratic equations using a method called just taking square roots. Okay? We're going to solve a quadratic equation by finding the square roots. And the best way for me to show you this method is simply to work a problem. So let's go ahead and look at number 1. So number 1, they say to solve each equation by finding square roots. When you're doing this, this is a great method when you have no x term. Notice, looking at our equation up there, there's no just x. We have an x squared, but we don't have an x, right? So anytime you have only an x squared in your equation, solving by square roots is a perfect way to go about it. Okay, in fact, it's my preferred way if that's all I have. So the goal is we're solving for x. Therefore, we want to get the x squared by itself. So how would I do that? Divide by 3. Absolutely. So I'm going to divide both sides by 3. So I now have x squared equals 25. Now, I realize that many of you are probably in your head already saying, okay, so I know what x is, and you're writing it down. That's great. That's wonderful. I'll bet that many of you who just did that got half credit wrong. Okay? Because when we're solving this, we're asking ourselves, what number, when we square it, equals 25? Okay? That's the question we're asking ourselves. Now, how do we get there? Well, of course, I think you guys saw this in Algebra 1, that if you have an x squared and you're solving for x, how do you undo that power of 2? Square root it. Yeah, we take a square root of both sides. Okay? We take the square root of both sides. So now the square root cancels with the power of 2. And we're left with x. But now here's the big deal. Okay? And this is a rule that I want you guys to remember for the rest of the school year. Okay? And it actually holds true beyond. But one thing that is not, you're not going to find it in the book, but one thing that I want you to remember for the rest of the school year. If you put in a square root, you get 2 solutions to it. Anytime you write in a square root, you get 2 solutions for it. And that's when we're solving equations. When we're solving equations, I'm the one that put in the square root there, right? It wasn't originally a square root of 25. I put it in there. Well, you guys all know what's the square root of 25? 5. But I get 2 solutions. So my solutions are positive and negative 5. Anytime you take the square root of something because you put it in the problem, you get 2 solutions. And of course, if you wanted to, you could have just listed it as 5 and negative 5. You didn't need to use the symbol, but it's much quicker just to use the symbol positive and negative. Okay, now why is that? Well, of course, you guys were all thinking when I said x squared equals 25, you guys all said, well, yeah, 5's the answer. And you're right, 5 is one of the answers. But remember, if I square negative 5, I also get a positive 25. Because negative 5 times negative 5 is still positive 25. So I get 2 answers. Okay? Questions on example 1? That's all we're doing in solving by square roots. That's it. Okay? Now there is another situation that you might have, because if you look at this problem, notice that x squared equaled a perfect square. And so it was nice and easy to figure that out. But let's take a look. I believe it's at example 3. Nope, example 2 is the one I want to look at here. Let's look at example 2. And we need to do the same thing. Okay, we need to do the same thing in example 2. We're going to solve it by taking square roots. So I want to get x squared by itself. So what's my first step? Add 96 to both sides. So that goes away, and I'm left with 3x squared equals 96. Well, again, I want to get x squared by itself, so now I have to divide by 3. And so I have x squared equals, well, 96 divided by 3 is 32. Sadly, 32 is not a perfect square. Okay? So We can still work a little farther ahead, though. We know that we're going to have to take the square root of both sides to get rid of that squared on the x, right? So I take the square root of both sides. So I now know that I have x equals, and I know that I'm going to get two answers because I'm the one that put in the square root. So I'm going to get a positive and a negative solution when I take the square root of 32. But I've got to decide what is the square root of 32. Do not give me a decimal answer. Don't plug that into your calculator and give me a decimal. Okay? It's 5 point something, but I don't care. I don't want a decimal. I want it written in radical form. So again, this is a review from Algebra 1. What you need to do is you need to try to factor it. Okay? If we have the square root, we can break the square root down into two square roots multiplied together. We want one of those numbers to be a perfect square. So here's the little trick that I've learned over the years. First off, you just need to know your perfect squares. I'm sorry, that's something you have to have memorized. So our perfect squares are 1, 4, what else? 9, 16, come on folks, 25, thank you, 49, 49. Now, if those of you who don't know where these are coming from, please remember all I'm doing is taking 1 times 1 to get 1. I'm taking 2 times 2 to get 4, 3 times 3 to get 9, 4 times 4 to get 16, so on and so forth. So 49 was 7 times 7. So my next one's going to be 8 times 8, which is 64. 81. 100. 121. 144. 169. 196. 225. So on and so forth. Okay? Now, in my personal opinion, you should at least have the ones I have up on the board memorized. Okay? And I would bet that most of you have most of those memorized, if not all of them already. But you should probably have those memorized. Now, what we need to do, the trick I was just about to tell you, is we're trying to take the square root of 32. We want to simplify it down. We want to leave it in radical form. Here's the trick. Take 32, cut it in half. What do you get? 16. So in your mind, or if you write these on a piece of paper, put a line where 16 is at. We want to try all the perfect squares that are equal to or less than half of that number, 32. Well, 16 is half that number. Is 16 a perfect square? Yes. So therefore, that's how this breaks apart. It's going to be the square root of 16 times the square root of 2. Okay? That's the trick. It helps you, give you a starting point. So you're not trying all of these perfect squares to see if they go into 32. Okay? And if we're doing it using a bigger number, that's a lot more helpful. 32 is actually fairly small. So it's not, you don't have a lot of choices. Okay? But let's say, just for the sake of argument, let's say we cut it in half, we got 16, but what if 16 wasn't a perfect square? Then what would I do? Well, then I would cross that out and go to the next smallest perfect square, 9. If that one didn't work, I'd cross it out and go to the next smallest perfect square, 4. If that one didn't work, I'd cross it out and then I'd be done. Maybe the square root of 32 is already reduced. It is in radical form as it is, okay? That's possible too. For example, the square root of 33. You can't break it down. There's no perfect square that can be factored out of 33. Okay? So, there's our process. We've broken it into the square root of 16 times the square root of 2. What is the square root of 16? 4. So therefore our answer is going to be positive and negative 4 square root 2. Okay? So, that is how we're working these guys. Please remember how to reduce the radicals. There's one example here. We will do more tomorrow if you need more help with that. Okay? Let's talk about homework.